नमस्ते दोस्तों, स्मार्ट माइंड्स ट्यूटोरियल्स में आपका स्वागत है। आइए आज कुछ नया सीखें।
So we will see how to diagonalize the given matrix. So first let us write given matrix. Given matrix is A is equal to 1, 2 minus 2, 2, 1 minus 4, 1 minus 1 minus 2. Now first we need to find the characteristic equation. So what is the formula for characteristic equation? It is determinant of A minus lambda I is equal to 0. So first we need to write A matrix 1, 2 minus 2, 2, 1 minus 4, 1 minus 1 minus 2. Minus lambda I is lambda 0, 0, 0 lambda 0, 0, 0 lambda is equal to 0. So if you subtract these two, you will get 1 minus lambda, 2 minus 2, 2, 1 minus lambda minus 4, 1 minus 1 minus 2 minus lambda is equal to 0. Now we need to expand this determinant. So if you expand, what will you get? 1 minus lambda into 1 minus lambda into minus 2 minus lambda minus 4 minus 2 into minus 4 minus 2 lambda plus 4 minus 2 into minus 2 minus 1 plus lambda is equal to 0. So if you open the brackets, what will you get? 1 minus lambda into lambda square plus lambda minus 6 minus 2 into minus 2 lambda minus 2 into minus 3 plus lambda is equal to 0. If you open the brackets, what do you get? Lambda square plus lambda minus 6 minus lambda cube minus lambda square plus 6 lambda plus 4 lambda plus 6 minus 2 lambda is equal to 0. So that is, now you see lambda square minus lambda square cancel, plus 6 minus 6 cancel. So what are you left over with? Minus lambda cube minus 9 lambda is 0. So if you take minus lambda common, you will get lambda square minus 9. Here you will get plus lambda. So you will get lambda square minus 9. So lambda into, we can split this into factors, lambda plus 3 into lambda minus 3. So lambda values are 0, 3 and minus 3. So these are the eigenvalues. Therefore, what are the eigenvalues? Eigenvalues of A are 0, 3 and minus 3. Now let's say x is equal to x1, x2, x3 be the corresponding eigenvector to lambda, that is Ax is equal to lambda x. So you will get A minus lambda I into x is equal to 0. So what do you get? 1 minus lambda, 2 minus 2, 2, 1 minus lambda minus 4, 1 minus 1 minus 2 minus lambda. This matrix into x, x1, x2, x3 is equal to 0, 0, 0. Let's take this as equation number 1. Now we need to find eigenvector corresponding to lambda is equal to 0. So substituting lambda is equal to 0 in equation number 1. So what do you get? 1, 2 minus 2, 2, 1 minus 4, 1 minus 1 minus 2 into x1, x2, x3. Now to simplify this, sum of the elements of A matrix should be 0. Then only we can simplify the equations. So we need to apply row operations here. Let us make these two zeros. So how can you make these two zeros? R2 is R2 minus 2R1 and R3 is R3 minus R1. So what do you get? First row is as it is. Second row is R2 minus 2R1. So 0 minus 3, 0. Then third row is R3 minus R1. So that is 0 minus 3, 0. Into x1, x2, x3 is equal to 0, 0, 0. Now, if you equate, if you multiply them, what do you get? x1 plus 2x2 minus 2x3. Then minus 3x2. Then here also minus 3x2 is equal to 0, 0, 0. Now, minus 3x2 is 0. So, x2 is also 0. Now, if you substitute this in the first equation, you will get x1 plus 2x2 minus 2x3 is 0, right? So, x1 plus 0 minus 2x3 is 0. So, x1 is equal to 2x3. So, if you put x3 is equal to k, then x1 will become 2k and x2 is 0. So, what is the first eigenvector? First eigenvector is 2, 0, 1. Now, the same way we need to find out eigenvector corresponding to lambda is equal to 3. So, substituting lambda is equal to 3 in equation number 1. So, what do you get? 1 minus 3, 2 minus 2. 2, 1 minus 3 minus 4. 1 minus 1 minus 2 minus 3 into x1, x2, x3 is equal to 0, 0, 0. So this is minus 2, 2 minus 2. 2 minus 2 minus 4. 1 minus 1 minus 5. Into x1, x2, x3 is equal to 0, 0, 0. Now if you multiply this, what do you get? Now before multiplying, we need to reduce this. So let us make these two as zeros. So what to do? R2 is R2 plus R1 and R3 is 2R3 plus R1. So those two elements will become zeros. First row we are not changing. Now second row you will get 0, 0 minus 6. Third row you will get 0, 0 minus 12 into x1, x2, x3. Now you can multiply them. You will get minus 2x1 plus 2x2 minus 2x3 is 0. And one more equation is minus 6x3 is 0. So you will get x3 as 0. Now substitute this in this equation. You will get minus 2x1 plus 2x2 minus 0 is equal to 0. So 2x1 is equal to 2x2. So you will get x1 is equal to x2. So if we take x1, if we take as k, x2 is also k and x3 is 0. So what is the second eigenvector? 1, 1, 0. We need to take coefficient of k always. Now after this we need to find out eigenvector corresponding to lambda is equal to minus 3. Now substituting lambda is equal to minus 3 in first equation. So you will get 4, 2 minus 2, 2, 4 minus 4, 1 minus 1, 1 into x1, x2, x3 is equal to 0, 0, 0. Now again we need to reduce the first matrix. So R2 is 2R2 minus R1 and R3 is 4R3 minus R1. So that is 4, 2 minus 2, 0, 6 minus 6, 0 minus 6, 6 into x1, x2, x3 is equal to 0, 0, 0. Now we will apply R3 is R3 plus R2. So that last row will become 0. 4, 2 minus 2, 0, 6 minus 6, 0, 0, 0 into x1, x2, x3 is equal to 0, 0, 0. Now if we multiply this, what do you get? 6x2 minus 6x3 is 0. From here you will get x2 is equal to x3. Okay, now what is the first equation? 4x1 plus 2x2 minus 2x3 is 0. Now 4x1 plus 2x2 minus 2x2 because x3 is also x2. x2 and x3 both are equal. So this will become 0. So you'll get 4x1 is 0 and so x1 is equal to 0. So what is the third eigenvector? If we take x2 and x3 as k, you'll get 0, 1, 1. Now you got all the eigenvectors. Okay. Now after getting all the eigenvectors, we take matrix P. Matrix P is x1, x2, x3. So that is first eigenvector I am writing column wise, then second eigenvector, then third eigenvector. Okay. Now if I want to find determinant of P, 2 into 1 minus 0 minus 1 into 0 minus 1. That is 2 plus 1 which is equal to 3. Now 3 is not equal to 0, right? Therefore P inverse exists. Now how to find P inverse? 1 by det A into adjoint A. Now directly I am doing adjoint. So 1 by 3 into 1 minus 0, minus of 0 minus 1, 0 minus 1, minus of 1 minus 0, 2 minus 0, minus of 0 minus 1, 1 minus 0, minus of 2 minus 0, 2 minus 0. In our previous classes, I have shown you how to find out adjoint A. Now you have to take transpose of this matrix. So that is 1 by 3 into 1 minus 1, 1, 1, 2 minus 2, minus 1, 1, 2. This is P inverse matrix. Now we need to take diagonal matrix. What is diagonal matrix? Diagonal matrix is given by D. That is, what is the formula for diagonal matrix? D is equal to P inverse AP. Now we need to multiply 3 matrices to get this D matrix. So this is 1 by 3 into what is P inverse matrix? 1 minus 1, 1, 1, 2 minus 2, minus 1, 1, 2 into what is A matrix? 1, 2 minus 2, 2, 1 minus 4, 1 minus 1 minus 2. And what is P matrix? 2, 1, 0, 0, 1, 1, 1, 0, 1. Okay, now first I am not disturbing the first matrix. I am writing it as it is. Now we will multiply these two matrices. So what do you get? First row with first column. So 2 plus 0 minus 2. 1 plus 2 minus 0. 0 plus 2 minus 2. Now second row with all the three columns. 4 plus 0 minus 4. 2 plus 1 minus 0. 0 plus 1 minus 4. Now 2 minus 0 minus 2. 1 plus 1 minus 0. 0 minus 1 minus 2. So that is 1 by 3 into 1 minus 1, 1, 1, 2 minus 2, minus 1, 1, 2. Now what if you multiply this? You'll get 0, 3. Let me check this first row, third column. This is 0 plus 2 minus 2. Okay. So this is also 0. Now 0, 3 minus 3. 0, 2 minus 3. Now after this we need to multiply these two matrices. First row with first column. 0 plus 0 plus 0. Then first row second column. 3 minus 3 plus 2. First row third column. 0 plus 3 minus 3. Now second row first column. 0 plus 0 plus 0. Second row second column. 3 plus 6 minus 4. Then 0 minus 6 plus 6. Now third row third column. 0 plus 0 plus 0. Then minus 3 plus 3 plus 4. Then 0 minus 3 minus 6. So this is 1 by 3 into 0, 2, 0, 0, 5, 0, 0, 4, minus 9. So this is the diagonalized matrix D. Take the next question, diagonalize the matrix. So first let us write the given matrix. So given matrix is A is equal to 8 minus 6, 2. Minus 6, 7 minus 4. 2 minus 4, 3. Now first, let us assume that lambda be the eigenvalue of A. So what is the formula for characteristic equation? The characteristic equation of matrix A is determinant A minus lambda I is equal to 0. So if you find A minus lambda I, you will get 8 minus lambda. Directly I am writing here. Minus 6, 2. Minus 6, 7 minus lambda. Minus 4. 2 minus 4, 3 minus lambda is equal to 0. Now we expand this determinant. So how do we expand? 8 minus lambda into 7 minus lambda into 3 minus lambda minus 16 plus 6 into minus 18 plus 6 lambda plus 8 plus 2 into 24 minus 2 into 7 minus lambda. So that implies this is equal to 0. That implies 8 minus lambda into, now multiply these two brackets. 21 minus 7 lambda minus 3 lambda plus lambda square minus 16 plus 6 into 6 lambda minus 10 plus 2 into 24 minus 14 plus 2 lambda equals to 0. That implies 8 minus lambda into If you simplify this bracket, you will get lambda square minus 10 lambda plus 5 plus 36 lambda minus 60 plus 2 into 10 plus 2 lambda is equal to 0. So if you multiply these two brackets, you will get 8 lambda square minus 80 lambda plus 40 minus lambda cube plus 10 lambda square minus 5 lambda plus 36 lambda minus 60 plus 20 plus 4 lambda is 0. Now if you simplify this, you will get minus lambda cube plus 18 lambda square minus 45 lambda equals to 0. See here, 40 plus 20 is 60. 60 minus 60 cancel. So here if we take minus lambda common, we will get lambda square minus 18 lambda plus 45. If you factorize this, you will get lambda into lambda minus 3 into lambda minus 15 is 0. So we get lambda values as 0, 3 and 15. These are the eigen values. Now let x be the given vector corresponding to eigenvalues lambda. So a minus lambda I into x is equal to 0. So that means 8 minus lambda minus 6, 2. Minus 6, 7 minus lambda minus 4. 2 minus 4, 3 minus lambda into x1, x2, x3 is equal to 0, 0, 0. Now we will find out eigenvector corresponding to lambda equals to 0. Eigenvector corresponding to lambda equals to 0. So if we substitute lambda equals to 0 in equation number 1, what do we get? 8 minus 6, 2. Minus 6, 7 minus 4. 2 minus 4, 3. Into x1, x2, x3 is equal to 0, 0, 0. Now if we expand this, like if we multiply this, you will get 8x1 minus 6x2 plus 2x3 is equal to 0. Minus 6x1 plus 7x2 minus 4x3 is equal to 0. 2x1 minus 4x2 plus 3x3 is equal to 0. Now let's say x3 and x2 both are equal. That is equal to some k1. Then x1 will become 1 by 2 k1 if you substitute these values here. Therefore, what is the eigenvector? Eigenvector is x1 is equal to 1 by 2, 1, 1. Now the first number is in fraction. To remove it into a whole number, we multiply with 2. So this will become 2. Sorry, this will become 1, 2 and 2. What did we do here? Multiplying with 2. So we got one eigenvector. Now the same way we will find out eigenvector corresponding to lambda is equal to 3. So if you substitute this lambda equals to 3 in first equation, you will get 5 minus 6, 2. Minus 6, 4 minus 4. 2 minus 4, 0. into x1, x2, x3 is equal to 0, 0, 0. Now if you multiply this, you will get 5x1 minus 6x2 plus 2x3 is 0, minus 6x1 plus 4x2 minus 4x3 equals to 0. Then 2x1 minus 4x2 plus 0 is equal to 0. So from the third equation, you will get 2x1 is equal to 4x2. So you will get x1 is equal to 2x2. Now, if you take x2 is equal to some k2, then x1 will become 2k2. Now substitute this two values in any one of the equation. You will get 5 into 2k2 minus 6 into k2 plus 2x3. Okay. So what can we do here? If x2 is k2, then x1 is 2k2 and x3 will become minus 2k2 if you substitute. So what is the eigenvector? Eigenvector is x2 is equal to, what is the coefficient of k2 in x1? 2. Then in x2 it is 1. In x3 it is minus 2. This is the eigenvector. Now let us find out eigenvector corresponding to lambda equals to 15. So what do you get? Directly I am writing the equations. Minus 7x1 minus 6x2 plus 2x3 is equal to 0. Minus 6x1 minus 8x2 minus 4x3 is equal to 0. 2x1 minus 4x2 minus 12x3 is equal to 0. Now let's say x3 is k3. Then x2 will become minus 2k3 and x1 will become 2k3. So what are the eigenvectors? You will get eigenvectors as 2, minus 2 and 1. Now we can name these matrices as model matrix. Model matrix P is x1, x2, x3. So P is equal to 1, 2, 2, 2, 1 minus 2, 2 minus 2, 1. So determinant of P is 1 into 1 minus 4 minus 2 into 2 plus 4 plus 2 into minus 4 minus 2. That is minus 3 minus 12 minus 12, which is equal to minus 27, which is not equal to 0. Since it is not equal to 0, you can say P is a non-singular matrix. And so P inverse exists. So what is P inverse? 1 by determinant of P into adjoint of P. Here directly I am writing the adjoint. Minus 3 minus 6 minus 6 minus 6 minus 3 6 minus 6 6 and minus 3. So this is P inverse matrix. Now let us find out AP. What is AP? 8 minus 6 2 minus 6 7 minus 4 2 minus 4 3 into what is P? 1 2 2 2 1 minus 2 2 minus 2 1. If you multiply this, you will get 0 6 30 0 3 minus 30 0 minus 6 15. In the last problem, I have shown you how to multiply two matrices. I have given you the direct answer here. After finding AP, let us find out diagonal matrix. After P, we need to find out D. What is D? P inverse AP. That means we need to multiply P inverse matrix with AP matrix. So that is minus 1 by 27 into minus 3 minus 6 minus 6 minus 6 minus 3 6 minus 6 6 minus 3 into what is AP matrix? 0 6 30 0 3 minus 30 0 minus 6 15. Now let us multiply them. If you multiply these two matrices, you will get 0 0 0 0 minus 81 0 0 0 minus 405. So that is, if you take this 27 inside, you will get 0 0 0 0 3 0 0 0 15. This is D matrix, which is the diagonal matrix.